Okay, graphing. So every time you graph, make sure you're doing your labels. So let's start with, how many x's do I have on this one times altogether? 5. So it will be an x to the 5th. So I kind of know that, I know for sure the arrows would be doing that. There might be an extra bump in there. Okay, x-intercepts. We have an x-intercept at 1, at -2. You know what I'm going to do? I'm going to give myself a little lightly shaded B there so I remember to do a bounce later. And at 3, I'm also going to put a little B for a bounce. Okay, I need something labeled, so I'm just going to write 1 and then I'm good, because each tick means 1 on the x-axis. Okay, and then what is our y-intercept? That's the other thing I would need. So pretend x is 0. -1 times 2 squared times -3 squared makes a
-32.
What'd you get? -36?
Oh, 6. Well, 4 times 9 is 36.
Negative? Okay, I'm going to label it -36. So remember how I started out here? I knew my arrow was down. So the arrow is down. It's going to come up here, bounce. Has to go through, bounce. Remember, it has to land going up at the end. Okay, this one. How many x's would you end up at the end with multiplying x's?
3.
X cubed. Oh, there's a negative. So there, I know my general shape idea, right? Okay, what is the x-intercept on this factor? Just a 0. And then the other x-intercept is a -3. And again, I have to show you some kind of tick mark, so I just put a 1 on that tick mark right there. And what is the y-intercept? I don't even need to calculate it, because what is it? 0. It's already on the y-axis. It's at 0. If there's an x-intercept at 0, there's also a y-intercept at 0. So then your shape is, oh, I better wrote that out so I remember. A bounce there. So remember how I had to put my arrow? Had to be up here. So I'm going to bounce, and then at the very end there, it has to go down.
I know.
Okay, the last one says graph a quartic. So a quartic means 4 that has roots at -3 and 2, and it has a double root at 1. So it would bounce.
A double root means bounce.
Bounce.
The squared thing?
Okay. Ooh, I think on the test I gave you more information, which makes you have to do a slope and stuff. This has really nothing else. So I just need to graph a quartic. So what?
Slope. Like, can you do an example like that?
Should I just?
They can just add on to this one. So it's like the one on the test? Can you do that? What do you mean by slope?
Like I might say your multiplier is a -2.
Oh, like an A.
Like an A, yeah.
Oh.
Sorry.
And then you
Yeah.
just have, okay.
Yeah, you just have to do. Okay, so if I just say graph a quartic, then that would work. I could have gone with an M because it doesn't specify, right? So I think on the test I had a little bit more information that might make you do a specifically, like specifically a W, specifically an M.
So like it would be an,
I might.
it could be a negative value. Right?
Yeah. Yeah.
If A is like a real value, like it would be like a 2, that's only
No.
only affects the
Y-intercept. That's why it'd be just more specific. Right there, I just could do anything I want. Okay, equation making. This is very similar to your test. You have two equations. Okay, so here's an x-intercept at -2. So x plus 2 is the factor. Bouncing squared.
You say f of x or like what is this?
We can just do y equals because it doesn't, if it doesn't say, but if it says make an equation for p of x, then you write p of x or f of x or whatever it says. X minus 1 is a factor for the 1. Bounce. Then there's going to be an a value in it. What is something you already know about a? Negative. Okay, so now what do?
That's 4.
I plug in another coordinate, and I specifically am going to do the y-intercept because it's really easy to plug in with the 0 there. So if x was 0, so 2 squared, -1 squared. If x was 0, I should get a -8. So I replaced all the x's with 0. I replaced the y with a -8. And then
I can just kind of see what the number would be. Or what would it have to be.
so that ends up being -2, which we guessed. We guessed negative anyway, right? So you should now finalize it here. So rewrite what you started with, but now replace it, the a, right? Okay, this is a quintic, right? A 5. Okay, y equals a. I already know a is negative by the looks of it. Intercept at -1, so x plus 1 bouncing.
And it was in person too, so it wasn't offered up. Which made it weird.
Intersect at +1, so x minus 1. An intercept at 2, so x minus 2 with a bounce. Okay, not a very good graph on my part. I would for sure make sure your graph is visible. We're going to plug in the coordinate 0, 2 to see what happens. That's a 2.
I was just listening and I was like I really don't want to like read it all. But it didn't say anything to work or anything like that. No. I wasn't gonna say anything bad, but I like that, so yeah, throw it out there. But yeah.
So I'm actually getting a to be -1/2.
Or should it be negative 1?
That's fine.
That's okay.
Yeah. Okay. So that is the conclusion of your graphing. That's good. And equation making. Okay, synthetic division. Okay, so I'm going to do my box. I'm going to put a positive 1 on the outside. I'm going to check for gaps. Cube, squared, x, number, good. So just right. 5, -4, -2, and 3. Bring down the first. Diagonal times, add down. Diagonal times, add down, right? The method?
Yeah, so that's fine then.
Okay, and then this one says to write a division statement. So I'm going to do the whole works here. This divided by this equals, and then what did we come up with at the end? 5 what? 5x squared plus 1x minus 1, just the number. Then this is always the remainder, so we're going to write it as a fraction. So plus 2 over, you remember where you grab that from? X subtract 1. So on this one, I'm asking for the whole statement. So that's the whole division statement. Okay, I'm going to change this question. Let's say on this question I just want the quotient. I just want the quotient on the second question. Okay? So let's get just the quotient here. So divide -3 outside. Are there any gaps?
Yes.
The squared is a gap, right? So 1, 3, 0. Okay, see what you can do on your own.
Wouldn't it just be easier? Yeah.
I got a couple zeros, so yeah. Oh, you thought I would just continue the whole way?
Yeah. Because timesing anything by 0, but then I realized.
And then you got an adder in there, yeah.
Oh, that's.
Do we look the same on our box?
Yeah.
Okay, so this should be a 1 what? X cubed, x squared, x number remainder. That's kind of the order, right?
X cubed minus 10.
So I'm going to write x cubed, nothing, minus 10, plus 1 over x plus 3.
That's the quotient.
That's the quotient.
Okay.
So because there's zeros, you
Okay,
just
I'm good up till there.
I just didn't write, yeah. Skip. But I wrote down, just to remind myself, that's no x squareds, right? I like the place.
Could be anyone in Oklahoma.
Yeah, it could be 5 people.
Okay, without synthetically dividing, so you can't synthetically divide. Determine the remainder. So what do I do?
long division.
No, just, yeah, like a test. It's called the remainder theorem. So I plug in a positive 2. So 3 times 2 cubed.
Wait, why did you choose?
This is called the remainder theorem. I choose a positive 2 because it'd be the x-intercept, the root number.
Okay.
It's all the same with synthetic division because you always pick the same, the root number, right?
That's equals 0.
Whatever we get is the remainder, so
So negative 27 is the remaining?
what? Negative?
Oh, I didn't cube it.
Oh, do you square it?
Yep.
Or like you put the wrong button in.
Yeah.
Okay, that's it. That's my answer. The remainder is negative 15. Okay? If you want on a test, you can still check your answer with the synthetic division, right? Because if you did it, you should get a negative 15 at the very end as well, right? Determine if they are factors or not. So what am I going to do?
Like factors,
If this is a factor, what should we do?
you would put in like 1 or something.
Yeah, you test the negative 1 plug-in. Or you do a synthetic division with negative 1, because it doesn't say. Okay, I personally, on a test, would maybe just do both, because I like to see that my answers are the same, or whatever.
How's physics today?
It's all right.
Can you take notes?
Yeah.
Is anybody getting 6?
Where were you?
At an appointment? I got negative 2.
So either method, if you picked the testing method, the remainder theorem, or if you picked the synthetic division method, you should get a 6 remainder. So this is a yes or no question though. Is it a factor? No.
It never says you have to prove your work. So I could negative 2? I keep getting negative. Okay, whatever.
Are you doing this method?
Yeah.
Did you do this in brackets?
Yeah. Okay, whatever. I give up. Equals 6.
Okay, and then one more. So try it the same.
Because it would have had to be 0.
Right. So here you're going to be plugging in a positive 3, the root number, or if you're the synthetic divider, you put a 3 on the outside, whatever method.
Zero.
It's even at 215. Oh, okay. 250. Oh, okay. So soon. That's why I'm trying. That's why I'm talking fast. So the answer is yes, it is a factor because you have the remainder of 0. Okay, on your tests, I basically say verify yes or no, and I might say you have to verify it with both methods. Graph, and it told me that this is a factor. Now I gotta graph it.
Great.
Okay,
No, that is not.
so first of all, what do I know with just looking at the original here? There's 2 things you can tell me fast with the original. What shape is it? An N. And I also know something else very quickly. My y-intercept is 6. Okay, so that's what I know already. Okay, let's synthetic divide. We're going to put a positive 2 on the outside. FYI, this has to come out to be 0 because it told me.
Yep, that'll be good. I see.
Okay, so I'm going to go y equals x minus 2 times, what'd you get here? 1x squared. I really should have learned my words. Remember how I said I was going to do that last time?
Did you?
This divided by this is this, so therefore this times this is back to the top. This is and that's. Does this make sense? Division is that, timesing is back to that, right? Okay, and then can you give me
So, should
that? Can you give me that by hand now? Multiplies to 3.
Or,
you still do this?
I watch the movies on the weekend. They're good.
You also watch? You watch Guardians?
No. I was watching.
I watched.
Have
Really?
you?
Best movie I've seen all year.
I've
What?
watched it twice, buddy. Sir.
That and I'm kind of really like the
Come on.
outro.
I watched it. It was pretty extra meaty.
That's a bit too far.
Okay, so after
I'm not a avid
all of
movie enjoyer,
those
so
factors,
that's
we
okay.
got all the
Not
x-intercepts, got a y-intercept, we knew the shape. Make sure you put tick marks each somewhere, once on a y-axis, once on an x-axis.
Yeah, are you coming to the game?
Yep.
You should probably change the.
I'm gonna do that just on the bus.
Okay.
I don't change at school.
The grape one's not that bad.
Really? I kind of like them.
So this is the question that puts everything together.
Avatar and then not.
So we have to grab.
Maybe we can't be friends.
You're a horrible person.
Okay,
Sorry that my legs.
you are going to probably start with the remainder theorem, where you're testing something, plugging it in. What's the best number to test? What's
1.
1? So we're going to plug that 1 in. 1 cubed plus 2, 1 squared. Basically, I don't care the number, but does it or doesn't it equal 0? It equals 0? First time? Done. So I already know this. I already would know that, right? X minus 1 is a factor, right? Like that. So far. Okay, oh, let's talk about what else we know. What's the shape? What's the y-intercept? We can do those fast again. Shape, cubic, x cubed, so there's an n, y-intercept, 10. Okay, so now we go more. Synthetic divide with a positive 1 in the front. No gaps again, right? I don't even know if I checked that last time. Oops. 3, 2, 1, none. No gaps. Okay, remember that this should come out to be 0 because we tested it. Everyone got a 0 on that one because that was our goal. Okay, so then this part that's left is an x squared plus a 3x minus a 10. x squared plus 3x minus 10. And we'll break this last part down by hand. What multiplies to 10? You got something to do that? Multiplies to 10, adds to 3. Okay, so I have all 3 x-intercepts, my y-intercept, and I knew my shape. We had no bounces or flattens, so there's my shape. Okay, and look at my graph. I have at least one thing labeled on each axis, and then I'm good. Okay, I think we have some word problems next. Okay, this is a dolphin that's jumping out of the water. So the first thing I'm going to tell you on your test is check out your variables. This is using a t and an h. There's no such things as x's and y's anymore. Got it? So don't use x, use a t. Don't use y, use an h. So hint, hint on your test, I would deduct points if you use the wrong letters. Okay, for how long was the dolphin out of the water during its second jump? 2 seconds. So what were you looking at? You were looking at that, right? So how long of the time from 2 to 4 means they were out for 2 seconds. Determine the equation of the polynomial that models this situation. Were you going to ask me something? Yeah, but it says during its second jump. That's why. Yep. But if I had asked how long is it out of the water, you would have added. Yeah. Is that what you were thinking of doing? Yep. Determine the equation. So we're going to write h equals not t or not y.
Would you ever write HT?
Like this.
Like, yeah. Is that okay too?
Yeah, that's good. I thought that'd be more confusing, so I didn't. Okay. I need a factor that represents this intercept.
Negative T.
Just a t for, yeah, yes. So just if it's 0, it's just a t. This is at 1, so I'm going to write t minus 1 as another factor. Here's an intercept at 2, so I'm going to write t minus 2. And then I'm going to write at 4, so t minus 4. Okay, there is one more thing I need in this equation. A negative a, and I actually can't calculate it because I don't specifically know any points because of the way this graph is. So we're just going to write negative, just to make sure we know it's negative. Okay, so determine your best estimate for the max height reached by the dolphin. So here's the max, right about there. And then kind of if I thought about my ruler, it says kind of determine it with your best judgment according to this graph. What do you want to write? I think it's, looking at these tick marks, I feel like it's not quite 4. Anybody okay with that? If this is 2, I think 4 would be like that. I don't know. So I'm just going to go approximately, what do you want to do here? 3.7, 3.8. I don't know. Okay. So this one you can do with a graph because it just says the graph on it. We're gonna do one without the graph. Yep. That's why I picked this one with the graph. Volume. Okay, Chris, today this paper is a square. That's a square. So now I need to be able to draw a square box because I folded a square box. How did that go? To your liking, my drawings? I'm glad you're not in my calc class judging my ellipses and my... Okay, so if this is 8 and I cut off x here and x here, what is left after the fold? You remember how to do that? 8 minus 2x is left because I had 8 and I cut off an x and an x. 8 minus 2x. And then do you remember what the dimension is once you fold that flap? X. So the volume equals 8 minus 2x, 8 minus 2x times x. Okay, I'm okay, leave it like that. Or I would also be okay with squaring this one because it's a box that's got a square base. If it's a rectangle, you can't do that, right? Graph. Okay, you ready? Tell me what x value causes this bracket to be 0. 4. 4 causes that to be 0, right? 8 subtract 2 times 4 makes 0, right? 8 minus 2x equals 0. Solving that, right? That's what you're doing. You're solving that. What's going to cause this bracket to be 0? 0. And do you know your shape? It's a volume. How many x's did we times? 3 cubic shape. And we have a bounce. N cubic bounce. Is there any parts of this graph that aren't applicable to us in real life? Before the 0 and after the 4. Also, there's another part that doesn't work. Exactly 0 and exactly 4 don't work as well. So if I write the domain, because I think I asked this on your test, how would I write the domain of what works? 0 to 4, but round. So why can't you have 4? Why doesn't 4 work? You would cut 4 and 4. You cut off your whole 8. Now there's no side left. So how can you make a box, right? Okay. Estimate the value that would produce the max volume. We're just going to, okay, forget this. Bad question, I don't like this. Just estimate a max volume. How about that? We'll just make the question. Estimate a max volume. New question. Just estimate the max volume. So one time I gave this example like where I changed the question and then I had somebody on a test just change the test question.
Is that allowed?
I was like, sorry, like to confuse you, I'm doing this. You're not allowed to just change questions.
Come on.
Oh my god.
I'm gonna do
Not
that.
doing
I'm gonna
this
do
one.
that when I it's going to a lot easier.
Oops. Okay. I know. I'm going to change this question and see if she's going to grade this one right, because I know how to do this
Then
one.
you'd technically still be right. If you change it to something you would be right at.
Okay, so if I'm estimating the max, what x value do we want to try? What makes a good x value to pick? You can plug in x equals 2, and I'm fine with that. Usually I just do the midpoint. There's a 0 to 4, so I just pick whatever's in the middle. It's not going to actually be your max, but it's an estimate. So I'm going to plug in 2. So again, looking at my equation from A, I'm replacing x with a 2. I made a replacement of x. $32, and I'm going to put some units on the end of that. Something with measurement stuff. Centimeters cubed. And I would have that expectation on a test that you would throw some units on it, or I would give you just a communicating error, like that small one I've been doing. You didn't get 32. Okay, wait. 8 subtract 2 times 2 is 4. Squared is 16. Times 2. What did you do? Did you add 2? Just something did you just make up a question like I told you nothing? Last question. Okay, so here's temperature and height. We are going to graph it. Let's pay attention to the letters again. On a test, I'm using T and H. I'm not going to be using X and Y. Okay, pay attention on your test. I will mark you wrong if you use the wrong letters. Okay, we know that the temperature is 0 at the first hour. So that is already, that's an x-intercept at 1. I also would know that h minus 1 is a factor. Okay, that is something I already know. So what can I do if I know that? Where would I go next? Divide it. Synthetic division. Okay, go. Set it up. What are you putting on the outside? Positive 1. Okay, positive 1 on the outside because that was one of your intercepts. You better be getting a 0 on it because it told us we should. Okay, so the equation, so temperature equals h minus 1 was the first factor before we divided. And then what do we get on the left over here factor? H minus 7h plus 12. Everyone was good with that? They got that on their synthetic? Oops, squared.
Could you have it already in three brackets? Like, could you say that was
That's where I'm going, yep.
But like, you could, if that's just what you wanted, you just wanted the.
Yeah, this is a really bad question because determine the polynomial, well, you could have just wrote the original. Like I really should have, the wording should have been write the polynomial in fully factored form. That's what I am going with here. Oh boy, what multiplies there? 3 and 4? Okay, so at the first hour, third hour, and fourth hour, the temperature was 0. Cubic. Anybody know what this y-intercept is right here? Just because I want to know. Just for information, it's not part of the question. Negative 12 from the original, it's faster. Okay. This is what it looks like, but I'm saying what is the highest the temperature goes in the first 4 hours? So looking at this kind of, right, I don't look at this because this is after the 4th hour. So forget that. So what is the max? How do you estimate that? Plug in, I think the 2x value would be best to plug in. So temperature equals 2 minus 1, 2 minus 3, 2 minus 4. So there's me plugging in 2 hours into the hour spot. Two degrees. Is that what everybody's getting? Not very hot. Should I tell you what the actual exact answer is? Because that's going to be fun. Carter, you should be up here doing this.
Sure.
You know how. Okay, so here's my function. Look at it. Does it look like what we just did? I graphed it. So I'm going to calculate the top. So calculate a max. And then I'm going to get my mouse. Where's my mouse here? There's my mouse. I'm going to say it's between here and here somewhere. So we had at 1.78 hours, the temperature reached 2.11 degrees. That's actually the highest. See how you won't know how to do that. But if with this calculator. Okay, that's why you have that estimate. See, yes, this is what we did in applied. We learned the same thing, but just with the calculator.